Alright, hey again, Honors Chemistry. I know I showed you the answer key to worksheet number 2 via slideshow, but I wanted to kind of work it out by hand so you could see it as well. I'm going to jump to question number 2, and this is what we're going to be doing a lot of when we get back. So, just to remind you, if I have same volume, same pressure, and same temperature, that means I must have the same number of particles in both of these boxes. So if I have 100 particles in here, I must have 100 particles in here. Even though these are two different gases, if I have the same volume, same pressure, and same temperature, I should have the same number of particles. What is reasonable to conclude about the number of particles? It's the same, right? So you could say they have the same number of particles. And we could have an arbitrary random number. So if I have 100 particles in here, I must have 100 particles in here at same volume, pressure, and temperature. Okay? Now we're going to make up a number for the rest of this worksheet, but let's say if I have the same volume, pressure, and temperature, let's just say I have like 4 particles. Okay, so I'll always draw something like this. Okay, if I have the same volume, pressure, and temperature, I'll have 4 particles in the box. So represent molecules of hydrogen and oxygen in the containers below. React these molecules to form water molecules, leaving no leftover gas. So right now, each of these is considered one volume. One volume. Okay? And I can see on the left side that I have 2 volumes of hydrogen. I'm going to call it H. And I have 1 volume of O. And we know from the video notes that I made you record that for every 2 volumes of H and 1 volume of O, I will get H2O, right? And H2O we'll see looks like, it'll probably have like 2 hydrogens and 1 oxygen, okay? So I'm representing hydrogen with a black circle, and I'm representing oxygen with a small white circle, okay? So if this is 1 volume, if I have the same pressure, same volume, and same temperature, right? So it's pressure and temperature in this volume, I must have the same number of particles. So I'll draw 4 particles in here. Okay? Same thing next to it. If I have a volume, I'll have a pressure, same temperature. I should have the same number of particles. 4. So these two have the same number of particles because it's the same volume, same pressure, and same temperature. Right? And we're assuming this is 1 volume because it's a box. And then same thing with oxygen here. If I have 1 volume of oxygen, I should have 4 oxygen. 4 oxygen atoms in here I'm putting. Alright, so I have the same number of particles in each of these boxes, and I have twice as much hydrogen here because I know that I need twice as much hydrogen to react with oxygen. And now, if I want to make my 1 volume of water, I know I'm going to make 1 volume of water. Let's see how I could do this. I know I'll need 2 hydrogens for every 1 oxygen, so I'll just like kind of pair them for right now. So 2 hydrogens, 1 oxygen. 2 hydrogens, 1 oxygen. 2 hydrogens, 1 oxygen. 2 hydrogens, and then 1 oxygen. I kind of just paired them. I'm going to make 1, 2, 3, 4 molecules of water, which is our number. All right, and that's going to go in 1 volume. I know if I have 2 volumes of hydrogen and 1 volume of oxygen, I will make 1 volume of water. So I'll do black circle, white circle, black circle, black circle, white circle, black circle, black circle, white circle, black circle, black circle, white circle, black circle. And if you count all the particles, they equal the same number of particles before. 4, 8, 12, 3, 6, 9, 12. Okay? And I have 4 particles in here. Right? Now, it doesn't matter that these are molecules, it's still 1, 2, 3, 4 different particles. And this is still one volume at the same pressure and temperature. All of these we're assuming same pressure, volume, and temperature. So all of these are at the same pressure, volume, and temperature, and I get four types of particles in each, and so I have 4 particles in here, 4 particles in here, 4 particles in here, 4 different particles in here, even though I have a total of 12 circles drawn. And then again, what do the H, O, and 2 in the chemical formula tell you about the composition of water? There are 2 H's for every 1 O. And that is how we're going to do the rest of this worksheet. So when we get back, we're going to do more of this kind of grouping and coupling together to do chemical reactions.